Hello everyone, welcome to Pepcoding. In this video, we will look at the question range addition. Okay, let's see. Let's take the problem statement and also the input. Okay, now we will make an array or a vector. Okay, and we are going to make a vector of length 5. Okay, so 1, 2, 3, 4, and 5. Okay, so we have this vector, and at every position there is a 0, right? Now it is saying that we are given some queries like this. Okay, we are given some queries, we can say updates or queries. So the question is, assume you have an array of length n initialized with all zeros and are given q queries to update. Each query is representing a triplet, and what is it representing? Starting index, ending index, and increment. Okay, so we have a starting index here, a ending index here, and an increment here. Okay, now we have these queries and we have an array. Now using these queries, I have to make changes on this array and I have to return the answer. So what is going to happen? Let's say I have this query 1. Okay, in the first query, it is saying that I have a starting index of 1, ending index of 3. So starting index of 1 and an ending index of 3. So I have this range and we have to increment 2. Okay, so at this range from 1 to 3, I will increment every number by 2. Okay, so I have 1 to 3 range and I will increment every number by 2. Okay, now we have our second query. It is saying that we have a starting index of 2 and an ending index of 4. So we have this range and we will increment our number or we will increment all of our numbers in this range by 3. Okay, so this will be 2 plus 3, which is 5. This will be 5 as well, and this will be 3. Okay, and the next query is saying that we have a starting index of 0 and an ending index of 2, and we have to increment every number by -2. So starting index of 0, ending index of 2, and we have to increment our every number by -2. So this will be -2, this will be 0, and this will be 3. Okay, so at the end, after I've performed all my queries on my on this vector, I should get an answer which looks like this. So there will be -2, 0, 3, 5, and 3. Okay, this should be my answer. Now let's check the question. Okay, so this is my answer that I have to return. Okay, -2, -2, 0, 3, 5, 3, 5, and 3. -2, 0, 3, 5, and 3. So this is going to be my answer. Now, looking at just this, what we've done so far, what we've done is we've took the queries, and for every number, we have traversed the array and we have incremented in that range. Okay, from our starting index to ending index, right? So the brute force approach might be very clear. It is to just do that, to just traverse from my starting index to the ending index and increment every number in that range. Okay, so that is my brute force way, which means that let's say I have an array like this, right? And my starting index is 0 and my ending index is 5. So I will traverse this whole 0, 1, 2, 3, 4, and 5. I'll traverse all these numbers and I'll increment every number, right? I'll do that. So that is going to be my brute force approach. Okay, and that this is what we did in our question explaining part. Okay, so in this brute force way, we have all these queries, right? Now let's say that my first query went from 0 till n. Okay, so the starting index was 0 and the ending index was n. So it is asking me to traverse the whole array, right? Same for query second, same for query third. So all of my queries are saying that I should travel the whole array, right? And let's say I have q arrays or q queries such like that. So what is going to be the time complexity of this brute force approach, right? I'm going to traverse this whole these whole array or of q length q number of times, right? I'm going to perform these queries on this n length array q number of times. So my time complexity will be big O of qn, right? This is not a very good time complexity. If the number of queries was equals to the number of length of the array, then my time complexity would have been O of n square, right? This is not a very good time complexity. So we need to optimize it a bit. Okay, so let's look at the optimal approach, how we are going to solve this question using the optimal approach. Okay, so let's take the input here. Okay, now in this optimized approach, we are going to discuss the what part first, and then we are going to discuss why we did that. Okay, we are going to discuss what are we doing, and then we will discuss why are we doing what we are doing. Okay, so the first thing in this approach, let's make the array first, right? This is 0 0 0 0 and 0 0 1 2 3 and 4. Okay, this is going to be my resultant vector. Now in this vector I have my length 5 and I have these updates, right? Now let's write the steps that I'm going to do. Okay, let's put this here. Let's write the steps. Okay, so what is going to be my first step? My first step is going to be that my impact will happen on starting index, and the impact will be plus increment, right? And my second impact will happen on ending index plus 1, right? And that will be minus increment. If this is not clear, this will be in a few seconds. So what we're doing is we have this starting index and we have this ending index, right? And we have our increment. Now I'm saying that the impact I will do that before I was doing like I had 1 to 3, right? If I had a range of 1 to 3, I was doing the impact in the whole range. But now I will do the impact on only two indexes. Okay, the two indexes are SI and EI plus 1. So in this first query, let's say Q1, it says 1 3 and 2, right? So on the first this one is my SI. So on my SI I will do plus 2. Okay, or we can just write 2, right? And on my ending index plus 1, so my ending index is 3, right? From 1 to 3, and my ending index is 3. So I'm saying on ending index plus 1, I will do minus 2. Okay, this is what I'm doing. This is the impact, and the impact is only happening on two indexes. Similarly, I have, let's say, this second query, right? This is 2 4 and 3. So I have my starting index as 2, right? And here I'm going to do an impact of plus 3. But my ending index plus 1 is out of bounds, right? It is ending index is 4. It is saying that 2 to 4, right? The ending index is 4, but 4 plus 1 is 5, and 5 is out of bounds. So if we had an array which was greater than this, then on 5 I would have put minus 3, right? But here my ending index plus 1 is out of bounds, so I don't need to do anything. Okay, I don't need to do anything here. Now I have my third query, right? This is from 0 to minus 2, or from 0 to 2, and I have to do minus 2 as increment. Okay, so on the 0th index, this is my starting index. On my 0th index I will do minus 2, right? I am doing plus increment, right? But on my ending index plus 1, which is 2 plus 1, which gives me 3, on my 2 plus 1, this is my ending index plus 1. On my ending index plus 1, I am doing minus of minus 2. Okay, so minus of minus 2, which is same as 2 only. Okay, so I can just write 2 here. I can just write 2 here. Okay, this is my resultant answer after I've performed these operations. So I've only performed these operations on 2 indexes, on my starting index and my ending index plus 1. If this is not clear at this moment, this will be as we perform the second step, because in my second step you will understand why are we doing these things. Okay, so what is my second step? In my second step, I will make a prefix sum array. So I will convert this normal vector to prefix sum. Okay, this is prefix sum vector. Okay, so what I am doing is I have this resultant, right? Now let's take this. Let's write the answers, which are minus 2, 2, 3, 2, and minus 2. Okay, this is my indexes. Now let's take a variable called sum, because I need to keep the track of the sum, right? This is going to be my sum, and it is 0 at the moment. Okay, so now I will try to make a prefix sum array. I'm pretty sure you already know how to make a prefix sum vector. So what I'm doing is, in my first iteration or in my first index, I will just have minus 2. This will add to my sum. I will have minus 2 here. So in my resultant, I'm going to write the resultant here. Right here, this will be 0, 1, 2, 3, and 4. Right. So on my 0th index, I will put minus 2. Right. Then minus 2 is my sum. It will add up with 2. It will give me 0 only. Right. So I will write 0 here. Right. Now I'm at 3. 3 will add with 0. It will give me 3. So I'll write 3 here. Now I have 2. 2 will add up with 3. It will give me 5. I'll write 5 here. Right. Minus 2. Minus 2 will add up with 5. Will give me 3. And I will write 3 here. Right. So after parsing this, and after making the prefix sum vector, I get this as my answer, which is minus 2, 0, 3, 5, and 3. Now let's look at the actual answer. It was minus 2, 0, 3, 5, and 3. So I got the answer. I got the answer without actually traversing this whole array few number of times, right? If I didn't traverse the whole range, right? I only did that work for 2 indexes, for my starting index and for my ending index plus 1. And I did that impact of plus increment and minus increment. And after that, I made a prefix sum vector. And as I traversed this prefix sum vector, I got this my answer. But why did it happen like that? Like why after traversing this, with prefix sum vector, I got my answer. So what was so special in this part? Okay, so let's see. Let's say I have this. I'm only going to do this for the first query. Okay, so let's do this for the first query. Okay, so I have this 0, 1, 2, 3, and 4. Right, I have zeros here. When I said that I have to do 1 to 3, that my range is going to be 1 to 3, and I will increment 2. So I said that I will have this range 1 to 3. I will increment every number with 2. Okay, I'm going to increment every index with 2. But what does this actually mean? It means that my range of impact is between 1 and 3, right? I'm only incrementing the numbers between 1 and 3. Let's say my array was much bigger. Let's say my array was like this. Right? Let's say it was like this. And here we had 5, 6, 7, and 8. Right? We had 0, 0, 0, and 0. This was my array, and this was my query of 1 to 3 and 2. So it is saying that I will do 1 to 3 here, and all of these elements will be incremented by 2. But what if I say that I will increment all the numbers here So all of the numbers after incrementing will give me this, right? With 2 will give me this. But I need the numbers only between from 1 to 3. I don't need the numbers after that. So what should I do to make the impact last only in this range? What can I do? I can put -2 here, right? If I add all these numbers with -2, or the negative of, or the negative of or the negative of this impact, right, of this increment, if I add all these numbers after 3, right, after 3, if I add all these numbers with -2 or the negative of this impact, then all of the rest of the impacts of 2 are going to be nullified, right? They are just going to go away, because if I made an impact of +2, after making an impact of -2, it is going to not going to be present. Okay, so it will be destroyed. The impact of 2 will be destroyed if I add it with -2. Okay, so I am saying that from the range of ending index plus 1, this is my starting index, this is my ending index. So I'm saying that from the range of ending index plus 1 till end, if I do the reverse of that impact, if I do the reverse of that impact, I can remove the impact after this line. Okay, I can remove the impact after 2, after 3. If I want to remove the impact after 3, I only want my range to be 1 till 3, right? And if I want to remove my impact after 3, I can do ending index plus 1, right? I can remove all the numbers after ending index plus 1 by adding it with the negative of that increment, so that my total impact becomes nullified, and the impact only lasts till this range. Okay, I want my impact to be till this range only, right? So what I'm doing is I'm only making the impact last in this range. And how am I doing that? I'm removing all the numbers after that, after ending index, by decrementing it with the same increment. Okay, so how is this relevant with just two indexes? Okay, let's see. Let's take the first query only of 2. Okay, right? We have 0, 0, 0, 0, and 0. Right? We have the first query, and I am saying that I will increment all the numbers from here, from 1 to 3. Now, what if I increment just this number? Right? I'm going to, let's take this whole array again of a little bit longer length, so 5, 6, and 7. Right? I'm saying that I will do the increment on only this number on my starting index, not on my ending index. I'm not talking about my ending index here. I'm just doing the increment on my first index or my starting index. Okay, so from my starting index, I will I have this, right? I'm only doing this. Now let's make a prefix sum array of this. What is going to be my prefix sum array here? It is going to be something like this, right? 0. Now 2 will add to my sum, so 2. Now 2, 2, 2, 2, 2, and 2. I will get all the numbers as 2, right? This is my ending index. Now I'm introducing my ending index. My ending index is 3, right? So I want my impact to last only till this range, right? I want my impact to last only in this range. But how can I reduce that impact, right? How can I reduce the impact after this point, right? I need to reduce the impact after this point. So what if I put -2 here? Okay, I'm going to put -2 here at this point now. This is my ending index plus 1, right? I only want my range to be from starting index till ending index, right? So I'm going to put ending index plus 1 as my as the negative of my increment. Okay, so now let's try to find the prefix sum array of this of this vector. It will give me 0, 2, or let's write like this. Okay, good. So 0, 1, 2, 3, 4, 5, and 6 and 7. Okay, Now we have 0 here. Now we have 2, right? Prefix sum array, 2 will add 2, 2 will add 2, right? Now 2 will add to minus 2, and as 2 will add to minus 2, it will give me 0, right? Now 0 will add to 0, it will give me 0. 0 will add to 0, it will give me 0. 0 will add to 0, it will give me 0. So in this prefix sum array, after I did the prefix sum array of just this one query, you can see that the impact becomes relevant only in the range, right? The impact becomes relevant only in this range which I want. So after this parsing of my prefix sum array, it is the impact is only going to last in this range. So this minus 2 is here, so it can nullify the rest of the impact, right? It can nullify the impact after ending index. So from ending index plus 1, all of the numbers will be decremented by 2, right? If I reduce the sum by 2, the impact of 2 before that number is nullified, right? So all of the numbers after my ending index will be nullified with the impact of minus 2, right? The impact of 2 only lasted till here, then I introduced minus 2 here. So as I introduced minus 2, the prefix sum array gave me 2 minus 2, which is 0. The impact of 2 became nullified, right? The impact of 2 was destroyed, and that is what I want. I want my prefix sum array to I'm since only parsing this array once only, right? Now I'm parsing this array only once in my prefix sum vector. So I'm getting the answer only from this part. Okay. I'm sure if you don't understand this explanation, I would suggest you rewatch the part which you don't understand, because this is a very interesting question. Okay. So I hope the approach is clear. Now let's try to code this question. Okay. So what is the first thing we are doing? First, we'll make our vector, right? Let's call this resultant, and this will be of my length size. Now I have to traverse my queries. So int I equals 0, I is less than queries dot size plus I. I will take my starting index, which will be queries of I of 0, because at the 0th index, at every query column or every query row, at my 0th column I have my starting index. At my second column, or at my first column, I have my ending index, and at my second column I have my increment. Okay. Now let's write the abstraction of what we are doing. The first thing we are doing is starting index and ending index plus 1 impact. And what is the impact? Increment and minus increment. That is my impact. Okay. And after that I will find the prefix sum. Okay. So now I will check, or the first thing I'm doing is putting resultant of starting index plus equals to the query, or let's say increment here, right? I'm putting at the starting index of that resultant the increment which is required. Okay, I'm doing the impact of increment on my starting index here. Next, I will check if my ending index plus 1 is less than length or not. Okay, then only I'm going to do that, because at this moment you can see that at this point of ending index plus 1, I don't want it to go out of bounds, right? So at resultant of ending index plus 1, I will decrement my increment. Okay, so at this moment I am decrementing my impact. Now I've got this array. After this part, this queries, right? I've got this array or this array. Now I just want to find the prefix sum. To find the prefix sum, I will use a sum which is 0, and then I'll parse the whole resultant. So int I equals 0, I is less than resultant dot size plus I, right? And I have to return this resultant as well. Int, or let's say my resultant of I plus equals to, or I can say the answer will be plus equals to my resultant of I and at my resultant of I, I'm going to put that answer. Okay, so what I'm doing is, the first thing I'm doing is I'm putting the increment at my starting index and negative increment at my ending index plus 1. Here I'm checking if the ending index plus 1 is less than my length or not. Okay, because I want it to be in my bound, right? And in this prefix sum array, I'm saying that I'm finding a sum and I'm incrementing my sum. So this is actually sum, not answer, right? So I'm incrementing my sum with resultant of I, and my resultant of I is being replaced with my sum. So this looks fine. Let's run this code. Okay, this is successful. Let's submit this. Okay, the code is submitted. So I hope you understand this question. If you don't, I would suggest you watch the part which you don't understand. Please don't forget to like, share, and subscribe. Thank you for watching.